Hello everybody, Adam Hurd 973 Ramp here. First video I've done in a while. Today's video is on completely off the shelf single joint arm. Something I've been thinking about for a while. I guess last year would be an arm game, and I was mostly wrong about that, but I'm guessing again that next year will be an arm game, and maybe a lot of teams will need to make stuff like this. So I was curious how close you could get to zero fabrication, zero precision machining at least, for a single joint arm, and have something that's still functional and good. So luckily with the new Vex product line, we can get most of this done. So this single joint arm might look a little funky at first, but this is what a lot of teams did really well with in 05, like 330. A lot of teams in 07 and 2011 would have done something like this. And if you can imagine that you put a Vex Pro drivetrain down there, that's a full robot really. So first we'll start talking about the frame. So this is all that Versatubing frame. I would hacksaw all this stuff to length, get the clearance holes for shafts and stuff drilled in on a drill press, and grab your gussets and pin at this point. Next, come up, cross member here, these gussets, pin there. Don't tighten anything down yet. Important thing to do would be to measure from like this hole to this hole, do the same on the other side, and adjust everything until those numbers are the same, because then that means your frame is square. So then at that point, tighten all that stuff down. Next guy would be grab this. This is 1x1 angle. You can get it at a hardware store, that sort of thing. It's not Vex, obviously, but it's accessible enough. If you really wanted, you could use the 1-inch Vex tubing here. I would drill one of the holes off the robot, probably this one. Get it roughly to the right length, swing it into place, clamp it with a C-clamp, match drill through the frame. That'll add a lot of side-to-side stability, much more than these gussets will. These gussets set your dimensions nicely because they're real precise, but this is going to add a lot more strength. Next, this isn't pictured, but you can go and look at pictures of 330 in 05 or 07, get some more 1-inch angle, kind of hand bend it into a 3D shape and attach, like yay up there to somewhere down here. That'll be pretty strong. I guess the last frame thing is up here. You can see I have two Vex tubes side by side. That's because I really like the stability of 2 inches wide, both in terms of you have longer spread on your shaft and the actual arm is stiffer. So if you're doing custom machining, I would recommend just getting 2x2 tube, whether it's 8th wall or 16th wall, depending on the robustness you're looking for. But here you would do that. I think you just clamp them together, match drill at a bunch of different points along the length. If you bolt every foot or so, that should be pretty solid. All right, that's the frame. I guess we'll talk about the gearing next. So down here, so outside of this, I kind of checked that the ballpark range of doing like a 10-to-1 to 30-to-1, which would be a 1-stage or 2-stage versaplanetary with two 775s into the Vex Pro single speed, 12-2 sprocket, 62 sprocket out of 35 chain, really covers a lot of ranges. And I'll leave that as an exercise for you guys to go and check that math. One caution I would have, I didn't check the math on this, but the output stage here can be reconfigured to have, I think, like 12 to 40 and then 14 to 40 and like 18 to 40 or something. The 12 to 40 output probably wouldn't work. That's probably too much load on that pinion. So maybe do a little more reduction in these versaplanetaries in the name of getting a bigger pinion with a stronger tooth profile. This gearbox setup is pretty nice. It's not crazy expensive if this is the main joint on your robot and you're not doing too much else. It's got an integrated sensor mount that would work nice for an encoder, which I like. If you want to use a pot, a 5 or 10 turn pot would work nice here depending on how much arm rotation you're doing, whether you're staying in front or going all the way around. So that's pretty cool. I like that. I'm mounting it a little funky in the name of staying completely off the shelf. I'm using this Versa block to support an outer bearing. And how you get this mounted and match drilled up is a little funky. You would assemble it with just the Versa block. There's no bearing in this Versa block, by the way, just this one. You would have the shaft going through this bearing, this Versa block bolted to that one, clamping to the tube where you want it. And at this point, you've already drilled, this clearance hole in this tube for the shaft, but you haven't drilled these other holes yet. You would then put just this gearbox housing on the shaft, with the bearing and stuff to align it. So now you have everything lined up. And this whole part of the gearbox and all these gears wouldn't be here. You're going to come in and just match drill those two holes. And that's going to let you torsionally pin the gearbox pretty solid. So, not the greatest gearbox mount, but totally functional for what you guys are trying to do here, and it's completely off the shelf. If you had access to machining, if you could have a sponsor make one plate, or if you guys have a manual mill, a nicer mount plate could easily be made and clean this up. But certainly nothing wrong with this. You easily work well all season for you. Up top is a little funkier because we decided we're not going to do any custom machining, so it's a bunch of Versa blocks, which is kind of expensive. But once again, if this arm is your robot, it's not too bad. The plan here would be to use these outer Versa blocks as a sliding tensioner. You could use the Vex cam, you could make another cam, you could figure something else out. And these Versa blocks here are just for shaft alignment. So these outer Versa blocks have bearings that provide the rotation. These inner ones also have bearings that would technically rotate, but are really just there to get all the parts aligned, concentric. So I guess I'm going to open this subassembly for a little bit. And I know right now these widths aren't really that optimized, like these bolt heads on this Versa block and the bolt heads over here would be hard to get to. You might want to make this wider. I'll leave that as an exercise for you guys to play with. But you can come in and do Vex spacers, get all that stuff spaced out, shaft collar. The Vex 6061 shaft is nice because it's already good fit for the bearings. If you need more strength, you could get steel shaft on McMaster that's already precision ground. Save yourself a lot of work not having to round it for those bearings. Okay, so open this guy up and we're going to talk about this arm joint a little bit. Because I actually really like this part of it. So get it all jigged up using the Versa block and these bolts here. But these 6 bolts, especially being 832s, are not going to handle the torque load required for a real strong arm. So once you get it all bolted together, and I'd recommend actually bolting 2 or 3 more sprockets on here if you want spares, you're going to carefully, ideally on a drill press, could do it with a hand drill press would be better, drill this hole and this hole one shot. I would drill it right at 3/8. I'm recommending a 3/8 bolt there versus a clearance hole and just make that a real tight connection. You can buy spacers from McMaster here, just like the spacers for the 8s there you should buy from McMaster, or actually that the plastic Vex spacer might work there, the one-piece guy that does all 6 for you. But you could buy a spacer from McMaster for this part, or stack a bunch of washers. And now these 2 bolts combined will provide much better torque reaction than this bolt circle. I guess if you used that Vex spacer with these Versa keys, that would help a lot versus just the 832s. But for a big arm game where you're doing some serious business, I'm not sure what that's going to hold. But certainly these bolts out here will hold pretty well. One little thing I did that I really like when I model arms is I put the primary planes on this shaft here, so that if you want to get the weight of your arm, so it'll tell you the weight, it's 6.5 pounds, and it'll tell you the distance to the center mass. That would be these 3 numbers here. So if you were to check the math on your arm, you've made it really easy for you to put these numbers in another thing. You don't have your origin over here or something where you have to go, oh, my center mass is 12 inches. It's 12 inches from my origin to the center point. This is purely distance from your point of rotation. So if you're modeling this arm, it would be 6.5 pounds at about 19 inches. You could factor in that Z offset if you really wanted, or I guess that's Y, but that's not a huge amount. Obviously, 7 thou is not going to pull this off that much. And you want to be conservative anyway, so you'd probably say this is 19 inches and this is 10 pounds or something like that. Also keep in mind there's no claw or anything on this yet, which would greatly affect that number. All right, so I guess what could you do differently here if you had access to machining? Like I said down here, nicer plate there would clean things up a lot. You could really clean up this interface and not have so many bolts that are hard to get to, because like this as is probably would be a huge pain, because you could get all these bolts tightened up, but then you'd have to pull the shaft and put this arm in, put the shaft back in, fight for those spacers. So spreading this out a ½ inch or something would help a lot there. I just did this real quick to get the concept, so I haven't really iterated anything yet, and I probably won't. I'm going to post the CAD files for this so you guys can iterate on your own and improve as you want. But certainly this interface here could be cleaned up with access to custom machining. These blocks could be entirely omitted if you were using 2x2 eighth wall tube and just machined all the holes and stuff you wanted right into that tube, machine your sprocket mount into it, that sort of thing. One thing you could do that actually be really cool is you could put another one of these gearboxes over here, make this a lot wider, and in this gap that you just made, you could do 2 plate sprockets bolted together with the plastic Versa hub guy with bearings, and that's a free spinning guy. And that could be the virtual 4-bar with chain running down here, where you would have more Versa blocks and another arm joint, just like we did in 2011. So our 2011 CAD files are posted. You could make a totally off-the-shelf version of our 2011 arm doing that method, and that would be pretty cool. You could clean up things like this if you had access to your own gussets. It'd be a little more weight efficient and stuff, but that's really splitting hairs. I think this is pretty cool that you can make a really valid and robust single joint arm with pretty much off the shelf stuff. If you had this planned out, a couple people could make this in one weekend pretty easily. Maybe another weekend for your drive, and that's a pretty solid robot. All right, thanks for your time, and hope you guys learned something.